Lesson 5.1 Use Properties of Exponents. When numbers get very big or small, such as the mass of the sun, which is 5.98 times 10 to the 30 kilograms, or the size of a cell, we use scientific notation to write the numbers in less space than they would normally take. Properties of exponents will help you understand how to work with scientific notation. So, what is an exponent and what does it mean? An exponent is a superscript on a number. It tells the number of times the number is multiplied by itself. For example, x cubed is x times x times x because the exponent is a 3. The x is the base, the 3 is the exponent. So some properties of exponents. When you multiply with the same base, add the exponents. That's the product property. For example, x squared times x cubed is x raised to the 2 plus 3, because they're multiplying at the same base. Going to add the exponents, we get x to the 5th. The power of a product property is when you multiply in parentheses, like here, and then an exponent on the outside of the parentheses, you distribute the exponent to the two terms. For example, 2x cubed would be 2 cubed x cubed, or 8x cubed. Power of a power property, when you see exponent, parenthesis, exponent, you multiply the exponents. For example, 2 cubed to the 4th power. Notice it's 3 as an exponent, parenthesis, then another exponent. We'll multiply the exponents, so it's 2 raised to the 3 times 4, or 2 to the 12, which is 4,096. The quotient property is similar to the product property. When we multiplied with the same base, we added exponents. For divide with the same base, subtract the exponents. For example, x to the 4th divided by x squared be x to the 4 minus 2, or x squared. Power of a quotient property is similar to power of a product property. So we have a division in parentheses with an exponent on the outside of the parentheses. Distribute the exponent. So 4 over 2 cubed would be 4 cubed over 2 cubed, which is 64 over 8, which is 8. The zero exponent property says that anything with 0 as an exponent equals 1. So x to the 0 is 1. Negative exponent property says anything with a negative exponent, you reciprocal the base. So x to the negative m equals 1 over x to the m. Let's explain or see the pattern where this comes from. So 2 cubed would be 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. 2 to the 1st is just 2. Notice, every time the exponent is reduced by 1, the result is divided by 2. 2 cubed was 8, 2 squared is 4, 2 to the 1st was 2, so 8 divided by 2 is 4, 4 divided by 2 is 2. So that means when we reduce the exponent one more time and have 2 to the 0, it would be 2, which is 2 to the 1st, divided by 2, which is 1. And then if we reduce the exponent again, we'll have 2 to the negative 1. But the result will be what we had before divided by 2, so that'll be 1 over 2. 2 to the negative 2 would be 1 over 2 squared, or 1 over 4. And 2 to the negative 3 would be 1 over 2 cubed. which is 1 over 8. So let's simplify. 5 to the negative 4 times 5 cubed. I see that we are multiplying with the same base, the base being 5, so we'll add the exponents. So we end up with 5 raised to the negative 4 plus 3, which gives us 5 to the negative 1. That's a negative exponent, so we reciprocal the base. So it'll be 1 over 5 to the first, which is just 1 over 5. Here's another example. I see we have exponent, parenthesis, exponent. That means we multiply the exponents. So we'll have negative 3 to the 2 times 3, or negative 3 to the 6th power. And if we use our calculator, negative 3 to the 6th power is positive 729. Make sure when you use your calculator, you put the parentheses. Here's another one. I see a bunch of things that are multiplied together inside of parentheses. So we'll distribute the exponent. So we'll have 3 squared squared, x squared squared, and y squared. Which means we have 3 to the 4th, x to the 4th, y squared, and 3 to the 4th is 81. So it's 81, x to the 4th, y squared. Here's another type. And they look scary, but they're not. They're, as long as you do each individual step. First, we're going to multiply across with the same base. So we're going to take the 12 and the 2, because they're the numbers, the x's, and then the a's. So I have the 12 times the 2, the x's, and the a's times each other. On the bottom, I have the 2 times the 3, the x to the 4th, and the a squared. Which simplified gives that, because remember, if you multiply with the same base, add the exponents. If there is no exponent, assume it's a 1. So a is a to the first. So 2 plus 1 gives us 3. Then we're going to divide with the same basis. Since we're dividing, it means we'll subtract the exponents. So we're going to do the same basis. Here we'll have the numbers, the x's, and the a's. And we're subtracting the exponent. So x to the 5th divided by x to the 4th. We'll do 5 minus 4 is 1. So we have x to the first. And 3 minus 2 is 1. So we have a to the first. And now it's simplified. Let's try another. Same steps, multiply across, the same bases, add the exponents. So we have the numbers, the x's, and the y's. The bottom we have the numbers, the x's, and just the z. Simplify each of them. We're adding exponents. We have 2 and negative 3 make negative 1. Here negative 3 and 2 make negative 1. Negative 4 plus negative 2 makes negative 6. Anything with a 0 exponent is 1, so z to the 0 is 1. And 1 times anything is the anything. Now let's divide with the same basis, which means we subtract the exponents. So we have the 20 over 8, the x's, and the y. 20 over 8 is 1/4. For the x's, we subtract negative 1 minus negative 6 is 5, so it's x to the 5th. And then we have the y to the negative 1. That negative exponent there means we reciprocal the base. So instead of y, it would be 1 over y, so y will be on the bottom. And that's our answer. We have the 1 that's here isn't written anymore because 1 times anything is the anything. The y is going to go to the bottom because of the negative exponents. We have y to the first down here, but y to the first is just y. So, with scientific notation, Think of the leading numbers as the coefficients and the power of 10 as the base and exponent. So if I have 2 times 10 squared times 5 times 10 to the third, we'd multiply with the same base and add the exponent. So go ahead and multiply the 2 times the 5. Here, the 2 times the 5. And with the tens, we're going to add the exponents. Well, the 2 plus the 3. 2 times 5 is 10. 2 plus 3 is 5. So now I'm multiplying with the same base. This is 10 to the first, even though you don't see a 1, times 10 to the fifth, same base, add the exponents. That gives you 10 to the sixth. Since it's scientific notation, we write it as 1 times 10 to the sixth. And that's all there is for today. Have a good day.